This sample problem deals with the principles of static equilibrium. We're told we have a 26 kilogram stoplight. It's supported physically by two wires. There's a cable, a wire that comes up to point A that's attached to some other support, not interested in it. And we have wire C up to another support point here. There is no direct support above the stoplight. We're told the distances. A to B is 11 meters, B to C is 3 meters, and from the horizontal reference line down to the stoplight is 2.1 meters. Our task is to calculate the tension in this wire that goes to point A and the tension that goes to point C. We're going to say that the mass of the wires is not important, it's negligible. Well, let's list our data again here, and I put in the markings for the angles. There's an angle at this corner A. There's an angle theta C at the corner C. We want to calculate the two tensions. How do we make some progress here? Well, we observed this stoplight for a long time, and we see it's not changing its velocity vertically or horizontally. The acceleration is 0 in both the vertical direction and the horizontal direction. What do you know is the value of the net force if the acceleration is 0? The net force is 0 if the acceleration is 0. F equals ma. If the acceleration is 0, the net force is 0. And we're going to use this principle in both the horizontal and the vertical directions. Well, we're going to need the values of the angles, so let's do an intermediate calculation here. Let's find these angles. You have to kind of fill in, there's a right triangle that can be formed here with this vertical line. The tangent is equal to the length of the opposite side divided by the length of the adjacent side. Well, put your eye up here at corner C. Your opposite side is this 2.1 meters going down, and your adjacent side is the 3 meters, the distance from B to C. So we have tangent theta C is equal to 0.7 if you do this division. How do we find theta C? It's under the control of this tangent function. To get this symbol out of the tangent function, we're going to apply the inverse tangent function to both sides of the equation. You can't just do it to one side. You have to make the same manipulation on both sides of the equation. When we apply inverse tangent to the tangent function, we just recover this inner argument. So this left side reduces to theta sub c. On the right side with your calculator, if you apply inverse tangent function to 0.7, you get 34.99 degrees. In the same way, we can come up with theta A. We have a different triangle now. Still the opposite side for angle A, theta A, is 2.1 meters, and now we've got 11 meters running from A to B. But the principle is the same, this number is different, but you ought to pause and work this out in your calculator. I got 10.81 degrees for theta sub A. Now, our principle of static equilibrium, to get the net force of 0, in the horizontal direction, this wire A has a horizontal component that's trying to pull the stoplight to the left. There's a horizontal component of T sub C that's trying to pull us to the right. I'm going to claim that this direction to the right is the positive direction, so I'm writing a positive term here. And T sub C times cosine theta C. This calculation produces the horizontal component of T sub C. Again, you might want to make your own right triangle drawing on a piece of paper and convince yourself that this is true. The hypotenuse, T sub C, times the cosine of the angle theta C gives us this adjacent side. It's the horizontal component of force off to the right from wire C. Very similar, the tension in A has a component to the left that is produced by multiplying T sub A times cosine of theta A. In the vertical direction, now we need the vertical components here for both TC and TA. I'm going to claim upward is the positive direction. TC times sine of theta C gives us the upward component of T sub c. TA times sine of theta A gives us the upper component for tension in wire A. Notice both of these terms are positive. In the negative direction, we have mg, we have the weight of the stoplight. We know the mass of the stoplight is 26 kilograms, so we go ahead and take an intermediate calculation here. mg will be replaced on the next slide with 255.1 newtons. All right, in the horizontal direction, T sub c cosine of 34.99 degrees minus TA cosine of 10.81 degrees. You can do these trig functions on your calculator, and we come up with 0.8193. I'm rounding to 4 digits in my intermediate results, times T sub c minus 0.9823 times T sub a. Is it possible that this calculation would end up at 0? Yeah, it's possible because we've got a positive term here and we've got a negative term. So those are going to add to 0. That's what we're going to require to work the solution. In the vertical direction, we've got two positive components upward, and the 255.1 newtons, the weight of the stoplight going down. We find here two equations and two unknowns. T sub a and T sub c are both unknown. That's mathematically solvable, and I'm going to solve this by substitution, and we'll do that on the next slide. So first, in this horizontal direction, I'm going to solve for T sub c. I'm going to solve for a T sub c expression, not a number. But T sub c is equal to 1.199 times T sub a. You might want to pause the video and inspect this a little bit. This is just copied from the previous slide. I've moved this term to the right side so it becomes a positive. I divided by 0.8193 on both sides. So T sub c, wherever that appears, it can be replaced with 1.199 times T sub a. I'm going to substitute that into the vertical equation. I just copied from the previous slide the vertical equation, and now when T sub c appears, I'm going to replace it with 1.199 times T sub a. I can multiply here and I get 0.6875 times T sub a for this term. I have 0.1876 T sub a on this term, and we still have the minus 255.1. But I have like terms here. I have the same variable to the same power. So T sub a and a T sub a. I can add these two coefficients, and I get 0.8751 times T sub a is 255.1 newtons. Again, you might want to pause the video. If you divide both sides by 0.8751, we find that T sub a has a value of 291.5, 4 digits in an intermediate result. We were asked for T sub a. That's where I'm going to round in my problems to 3 significant figures. How's that going to help us? Well, before I go to the next slide, take a look back up here. Here is our substitution equation. T sub c as an expression can be calculated by 1.199 times T sub a. We just found T sub a. Let's go to the next slide and we'll get T sub c. So T sub a is 291.5. I put that in here to replace T sub a, and now I go a straight calculation, and I get 349.5 newtons intermediate result, round to 350 as a answer for T sub c. Well, I think I'm confident in my algebra. How could I check my work? Well, the horizontal components have to add to 0. Well, we know T sub c and T sub a now from our work on the previous slides. So I put those in. 349.5 is what we came up with for T sub c, cosine of that angle, and then minus T sub a was 291.5 and cosine of its angle. Does this equal 0? So a question mark here. We're testing this. Does this calculation produce 0? Well, again, pause on your own calculator, but with 4 significant figures, I came up with the same magnitude, force off to the right of 286.3 newtons, the component of T sub c to the right, and a force off to the left of 286.3 newtons. Those two forces balance. They add to 0. So, yeah, we're okay. We've checked our work, and we have a good solution to the problem. So I have many more physics and astronomy videos with short lectures and sample problems. They're indexed or annotated on my website, simple website, gpclements.com. This annotation has categories. It's organized by topic, the physics topic or astronomy topic, and you search through that, find a title that you're interested in. That title is actually a direct link to my YouTube video. You do not have to search on YouTube. You can click that link. The annotated list has the number of minutes that the video lasts and a little description of the calculation. I hope that's useful for you. All the content I have produced here is free. I don't charge for it. You're not allowed to charge somebody else for it. And you do not register with your name. You don't give me your email address. You don't give me any information. You just work sample problems and watch my solutions. And my website does not put cookies onto your computer. If you have questions, please ask your instructor.